In this video, we're looking at section 9.2, which is graphing linear equations in two variables using the form ax plus by equals c. In section 9.1, you learned how to find points on a line from an equation and how to plot the points. We're going to look at plotting linear equations on the Cartesian plane, and then we're going to look at specifically this pattern, ax plus by equals c. An equation in two variables is a model or a mathematical description of a situation. A visual representation of the model is the graph of the equation. The terms equation and graph of the equation are often used interchangeably. Every linear equation in two variables can be represented by a line on the Cartesian plane, or again, the coordinate plane. In section 5.1, we wrote down the definition of a line. And so let's remind ourselves here what that is. It's a straight set of points connected that goes on forever. And when we drew a line, remember we drew the arrows on either end to show that it goes on forever. And so when we graph a line and we want to determine if a point is on a solution or would be on that graph, what we need to do is to evaluate. Remember that means to plug in the equation at the point that they gave us to see if it simplifies to a true statement. So if yes, it is a solution. Obviously, if no, then it's not. So I think one of the examples that they were giving us from before was it came down to like 11 equals 11, which we know is true. Otherwise, if you get anything that doesn't match, then obviously it is not a solution. A line is made up of an infinite number of points. We just mentioned that. Each of these points can be represented by an ordered pair, remember x comma y, that satisfies the equation that describes the line. And we looked at last time how there can be many solutions to one equation. The equation that describes a line can take many forms. The standard form of a linear equation in two variables is ax plus by equals c. X and y are your unknown variables, and then a, b, and c just represent numbers. A and b are coefficients, so those front numbers to x and y, and c is your constant. So saying that the equation is in standard form means that the equation has the variables in alphabetical order on the left side of the equation with coefficients of a and b, and the constant c is by itself. So that's important to remember, that this is standard form. Because sometimes it might ask you to write an equation in standard form, and you'll need to know what that means. It means x and y numbers are on the left, and your constant without your variables is on the right. So true or false, if it is false, we need to fix it. So the equation 5x minus 7y equals 42 is in standard form. So our a value is 5 here, our b value is -7, and our c value is 42. And we have it in that pattern, and so this is true. For our second one, the equation y equals 5x minus 7 is in standard form. It's actually in a different form of a line, which we're going to talk about in the next section, so it is false. But we know it's not in our standard form because we can see that the x is on the right-hand side, not on the left-hand side with a y. And so to fix that, we would need to move it over to the other side. And In order to move it from the right to the left, we would subtract 5x from both sides. And remember, the x value has to come first. So we'll have minus 5x plus y. And yes, there is that invisible 1 there, so our b value would be 1 equals negative 7. So that's the equation in standard form. And for our third one, we have 14y plus 6x minus 3 equals 12. That's not in standard form either. And there's two things wrong. Well, first thing's wrong is that they put the x second, and it's supposed to go first. But the other thing is that we have minus 3 on that side, so we would need to move it over by adding 3 to both sides. And so when we fix both of those things, we will have 6x plus 14y equals 15. So that's the equation in standard form. When we're looking at graphing an equation in two variables, we've looked at this a little bit last lesson, you're going to find 2 points at least that satisfy the equation, and then you're going to plot those ordered pairs of those 2 points on the coordinate plane and connect them together with a line. And then it says you can find a third point just to verify that it falls on the line that you drew, and that's a way of checking your answer to make sure you didn't make a mistake. Oops. So here's an example. We have 2x plus y equals 8, and they want us to complete the table using x equals 1 for one solution and y equals 2 for the other solution. So if we use x equals 1, we'll have 2 times 1 plus y we need to find equals 8. So 2 plus y equals 8. We know it's 2 plus 6 to equal 8, but let's still show our math here as subtracting 2 to both sides. So as an ordered pair, that solution is 1, 6. And to graph it, we'll go right 1 space and up 6. And that, I think I counted right. It's right here. Yes, okay. So for our second solution, they want us to use y equals 2. So make sure you're plugging in these points in the right spot. So 2x plus 2x plus 2 equals 8. So we need to get rid of the 2 that's being added first. I don't know why it keeps jumping like that. It's not a negative. That was, I don't know what. But 2 times x equals 6. Now our final step is to get rid of the coefficient, or that front number of 2. So we get x equals 3. So we'll plug in 3 to our chart and write it as an ordered pair, 3, 2. And graphing means we're going right 3, up 2, and here's our second point. So then we need to draw a line through our points. And so let's see if I can get this. That looks good. I need to add my arrows on here since it didn't draw them for me. And so there is the graph for the solution of 2x plus y equals 8. They want us to verify our line by finding a third point and checking to make sure it goes on our line. So as I mentioned before, I like to plug in 0 when I can. And so we have 2 times 0 plus y equals 8. So that gives us y equals 8. So that ordered pair would be 0 for x, 8 for the y. And if we count up 8 boxes, we are right here where we're supposed to be. So it confirms for us that we did everything correctly. And what I just did was finding an intercept. That one is actually the y-intercept. The x-intercept is the point where the graph of the equation crosses the x-axis. This point always has a form a, 0, where a is a real number. So your x-intercept, your y value is 0 because you're not moving off of the x-intercept. You're not moving up or down. You're staying right on it. And so x-intercept, you plug in 0 for y and you solve. Now for the y-intercept, you plug in 0 for x and you solve it because it's going to cross the y-axis. So if you think, your first number, your x is left or right, we're not moving off of that y-axis, so we don't move left or right. That's why your x value is 0. Plug that in and solve it, and you get the number of spaces you need to count either up or down to be on that y-axis. So again, remember that you're using the opposite. X-intercept, y is 0, y-intercept, x is 0. So here's an example for us to try. And so for x-intercept, again, reminder, y equals 0. And so we have 4 times x plus 3 times now 0 equals 12. And anything times 0 is 0. So I was thinking of just eliminating this piece altogether. And then I can see that 4x equals 12. So when we divide by 4, we see that x equals 3. So as an ordered pair, we had 3 for x when we used 0 for y. And so the x-intercept is right here on the x-axis. For the y-intercept, remember x now equals 0. So we're doing 4 times 0 plus 3y equals 12. And again, anything times 0 is 0, so we could just ignore that. And then we see that it's 3y that equals 12. So if we divided the 3 off, we see that our y value equals 4. So when x was 0, y equals 4, and as an ordered pair, that's 0, 4. So we're not moving left or right again, we're just counting up 1, 2, 3, 4. And there's our y-intercept. So now we can graph it. And let's see, how will I do this? Looks pretty good. I'll add my arrows. And let's find a number that we can plug in and get an additional ordered pair to make sure that our equation is correct. In this case, I can't pick 0 because I already did, so let's pick a different number. Let's use 6 for our x value. So we have 4 times 6 plus 3 times our y needs to equal 12. 4 times 6 is 24, so 24 plus 3y equals 12. Okay, now that we have that, we need to get rid of our constant of 24 on the left. So we'll subtract 24 from both sides. So all we're left with is our y term on the left, and that equals negative 12 when we subtract. So when we divide by 3, we see that our y value is negative 4. So as an ordered pair, we use 6 for x and found negative 4 for y. So let's count to the right 6 spaces. 2, 3, 6, and down 1, 2, 3, 4. Oh, right here at the end where I stopped drawing my line. Perfect. So here's a couple examples for you to graph either way. You can plug in other numbers and substitute and find the equation. You can draw yourself a little table if you want to be able to fill in those numbers. Otherwise, you can use the intercepts. Plug in x equals 0 to find the y-intercept and y equals 0 for the x-intercept. If you do that for all of them, it'll be easy math, but notice that if you plug in zeros for 9, you'll get fractions or decimals, depending on what you want to put your answer in, which is fine. You can just do your best to graph those decimals on the graph. So take a minute and do those, check your work, and when you're ready, you'll move on to the story problems. Okay. So our first story problem, we're revisiting Barbara's Bombastic Bakery. And they're donating cookies to a charity bake sale. The bakery decides to donate chocolate chip cookies and peanut butter cookies by the dozen, and they want to donate a total of 30 dozen cookies. To determine the possible combinations, the baker uses the equation C plus P equals 30. C is number of chocolate chip cookies by the dozen, and P peanut butter cookies. And notice if we look at our graph, the C they wrote first and they use that as the x-axis, and P they wrote second and use that as the y-axis. So it's just like saying x plus y equals 30. So when we find the intercepts, remember we want to plug in 0 and then solve. So if we use C equals 0, we're just doing 0 plus P equals 30. And so we can see that just P equals 30, which makes sense. If you're not making any chocolate chip cookies, you need all 30 dozen to be peanut butter. So 0, 30 is that ordered pair. And we're going to do the same thing for our P equals 0. And we're going to get C plus 0 this time equals 30. So again, C equals 30. So that tells us if no peanut butter cookies are made, you have to make all 30 dozen chocolate chip. And so we will graph them. And since I don't want to try and make my graphs big enough to count to 30, I'm going to count by 5s. And so our y-intercept when C equals 0 is 30, so we're going to count up 5, 10, 15, 20, 25, 30, and put it here. And let's just show here that we're counting by 5s. And so then our 30 chocolate chip cookies, 30 dozen, I should say, 5, 10, 15, 20, 25, 30, we're right here. And so to draw our line, there we go. And I'll add my arrows. And so that equation is that graph. But then they're asking us, are there any solutions that don't make sense? Well, if we look at the graph, back here we would have negative chocolate chip cookies. Down here we would have negative peanut butter cookies. That does not make any sense. We're not going to have negative cookies. You might want to try and justify, well, if I ate them, they're negative. But we're not going that. So really, we need to stick to quadrant 1. One where both C and P are positive. So we can have no negative amounts. And so that's why a lot of times when you're looking at a graph that demonstrates some data, they don't even put the whole coordinate plane. They just put quadrant 1 on the graph because in most context story problems, it doesn't make sense to have negative values. And then our final question asks if we have Barbara's Fantastic Bakery donating 16 dozen peanut butter cookies. How many chocolate chips? So chocolate chips plus 16 the peanut butter still needs to equal to 30 total. So we'll subtract 16 from both sides and we'll get the chocolate chips would be 14 dozen cookies. Okay, for our next problem, we're looking at an ibuprofen example. Ibuprofen can be given to a child to treat a fever. For a light fever lower than 102.5, the recommended dosage is 2.2 milligrams per pound of body weight. This can be modeled by the equation D equals 22W, where D is the dosage and W is the weight. So we can create a table to determine several ordered pairs. And so if we look at our D, we know it's 22 times W. So 22 times whatever the W is. Sorry, not 22, 2.2. Let's not over-medicate them. And on this case, I didn't use 0 to plug in because it didn't make sense to me. I'm not going to be having a child that doesn't weigh anything. So I started with 10-pound child, and then 15, and then 30. So if we do 2.2 times 10, we'll get 22. 2.2 times 15 will give us 33. And 2.2 times 30 will give us 66. And all of those are in milligrams for ibuprofen. So now we need to graph it. And again, I counted by 5s because the numbers are getting kind of big. So for my first number, we had the weight of 10, so over 2 boxes for 10. And then we had 22, so 5, 10, 15, 20, a little bit higher than 20 for 22. For 15 pounds, we're up to 33 milligrams, so 5, 10, 15, 20, 25, 30. 33 is a little bit higher than half. And then for 30 pounds, 5, 10, 15, 20, 25, 30, we're up to 66 milligrams. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Oh, I already ran out of room. 55, 60, 65. 66 is going to be somewhere up here. And so let's draw our line. That looks like it's about right. And so again, let me add my arrows on it because it is a line, not a line segment. And so again, are there any solutions that don't make sense according to our story problem? So we're not going to have negative weights or doses. And so again, we would stick to quadrant 1 for answers that make sense in this context of the story problem. And so how much ibuprofen should be given to a 45-pound child? Since it's kind of hard to tell since we're counting by 5s in our graph, let's go ahead and actually calculate it. So the dose equals the 2.2 times the weight of 45, which would give us 99 milligrams of ibuprofen. Our final story problem, we have Mason buying an MP3 player and he spent $20 for it. And then when he downloads music, it's $1 per song. So they made the math kind of easy for us, which is nice. He wants to track how much money he spends, so he creates the equation C for cost equals 20 plus 1 n, and n is the number of songs. So to determine the several coordinate pairs that satisfies this, well, we can start off with an easy one. We know if he doesn't buy any songs, it's going to cost him $20. And then if he buys 5 songs, we would plug that in. So 20 plus 5 times 1, which will give us 20 plus 5, which is 25. And then 10 songs, we would do 10 times 1, so we're adding and getting $30. And so to graph this, let's count by 5s again on our graph. And for 0, we're up at $20, so 5, 10, 15, 20. Over at 5 songs, we're up at 25. And at 10 songs, we're up at $30. Oops. That'll be here. I went over too far. Fix that. So 5, 10, up $30. There we go. Draw our line. And add arrows. So there it is. So again, they're trying to remind us that in the context of story problems, sometimes only part of the graph makes sense. And so we're going to have stick to quadrant 1 because there are no negative dollar amounts or cost. I should say songs because the dollar amount is the cost. And so, again, the math's really easy for us. We know that if he buys 37 songs, it's going to be $57 because we're just adding that. But again, we want to show our work. So it's $20 plus $1 for the 37 songs. And so our cost will equal 57. So $1 a song gets kind of expensive when you're buying them one at a time. Okay, that's it for this lesson. If you have any questions while you're working through your homework, don't hesitate to screenshot it and send me an email. Otherwise, I'll see you next time.